Hey everybody, my name's John Broadwell and I am the creator of the Serial Wombat open source project. Today we're going to be looking at the Serial Wombat Backpack, which is a Serial Wombat 8B board that's designed to take off-the-shelf boards that already have some I/O requirements on them and turn them into I2C devices. The world kind of is already used to the idea of a backpack. Virtually all character LCDs now are converted from parallel interface to I2C. And I kind of took that idea with the Serial Wombat 8B and blew it way up using the Serial Wombat's capability of debouncing buttons, reading quadrature encoders, reading matrix keypads, all of those kind of things. And to facilitate that, I made the Serial Wombat Backpack. The thing that I think makes the Serial Wombat Backpack special is, well, first of all, there's 8 I/O pins that you can use for various things, analog or digital, rotary encoder, debounce buttons, whatever. But it's these 4 pins on either side. Essentially, each one of these pins can become SDA, SCL, ground, or VDD, depending on which of these jumpers you close. So it's really easy to create a backpack board that conforms to almost any existing board that you might get off of AliExpress or Amazon or, given to you by a friend or who knows what. But, and connect this up and then use the power and ground lines that come off of that. Boards like this one are particularly well suited to that because there's an OLED display that is I2C driven. So you're going to be driving power and ground and data and clock to this board anyway. Why would you want to have all these extra wires coming off of it when you can have the whole thing taken care of over I2C? So that's what we're going to be doing here. So let's look first at how we're going to connect up this board. We looked at another board in the past in another video that was more convenient. This one is slightly problematic because it has its SDA and SCL in between lines that we're going to want to make GPIO. So we can't necessarily put SDA and SCL on the edges. Fortunately, ground and VCC are. So what we're going to do is we are going to solder bridge this guy and that guy. That'll give us our ground and our VCC. Pin 7, 6, 5, 4 will go to the back button, the rotary encoder A and B, and the center push. Then we're going to have 2 pins that we are going to leave unpopulated, and we're actually going to put headers on these that are right angles. They'll point down at the bottom, and we'll have to use wires to hook those guys up. Then we've got our connection at the end. So we're going to have the back button, rotary encoder, push. We'll leave these 2 open. And then connection, or confirm rather, will be on pin number 1. Then we'll take these 2 pins and make them SDA and SCL. So we've got wires that we can hook up to those I2C lines that go into this guy. Finally, we'll add a right angle header to 4 of the pins right here so that we get power, ground, SDA, and SCL. We're also going to close the I2C pull-up line. That'll give us 2K2 resistors on the I2C lines. You should have that somewhere in your bus. We'll close this one so that we get a nice power LED on the backpack. Then we will close jumper number A4, and that will increase our I2C address from 0x60 to 0x64. And one more thing. The Serial Wombat chip has the ability to do a pulse on change for its various inputs. We're going to take advantage to that to drive an active buzzer. So every time you either push a button down or you change the rotary encoder, you're going to get a little blip. And for that, we will make one of these pins over here VDD, so it's always high, and then we will switch the buzzer on and off using GPIO Wombat pin number 2. So here's the board as it is finished. As we said, we were going to hook up ground and power and 4 of the IOs. We're going to leave these 2 disconnected so that there's space that we can put a right angle header on the OLED board. The OLED rotary board is blue. In this case, the Serial Wombat is green. In the final version that'll be available through our Kickstarter that's running right now, it is white. And then 2 more pins that will allow us to catch number 1, and then I had to put one in there for 0 because in my lab I didn't have a single socket that I could solder in there. You'll note that you can see 2 more solder connections here. We'll look at the other side of the board in a second. That is the buzzer. It is tied. You can see we closed the VDD solder jumper, so it's getting VDD, and pin number 2 will be a switched input. Here's the opposite side. We can see we put this header on the bottom. That'll let us drive power, ground, data, and clock to the board. And then obviously right here is our big old buzzer. This is how I configured the rotary board so I can plug it into the back of the Serial Wombat backpack. We've got our confirm button, our rotary push, rotary encoder A and B, back, ground, and 3.3 as straight up headers. Then I made these 2 come down so that I can plug a separate set of wires into them. Here we can see the final assembly, hooking up the 2 wires for SDA and SCL that I soldered into the Serial Wombat backpack board and plugging the thing together, and then we'll hook it up to an Arduino, in this case a Arduino Xiao, and that'll set us up for our next video. In the next video we'll show how to use the Wombat panel to configure the various pins, and we'll generate code for Arduino. Then we'll follow that up with another video where we show how easy it is to take the Arduino code and port it to MicroPython, and then that'll be followed up either in that video or in the next one where we'll show how easy it is to adapt it, and instead of using the Serial Wombat 8B, we'll plug the I2C rotary board directly into a Serial Wombat 18AB chip and show that essentially the code there is the same. It's all an ecosystem. The Arduino, the MicroPython, the Serial Wombat 18AB, the Serial Wombat 8B, they're all designed in a way where you can use the same architecture and the same concepts and move pretty seamlessly across the different technologies and across the different chips to fit your needs. So until we talk again, have fun and keep making stuff. If you get a chance, pop over to the Kickstarter and back that thing.